the condition of refrigerant before and after the condenser in a simple vapor compression refrigeration system is. In a simple vapor compression refrigeration system, you can see here on pH or TS diagram. Let us say on pH diagram. So at the end of the evaporator or at the exit of the evaporator, it is dry saturated, and here it goes to the dry steam, and from here it enters the condenser and leaves at the condition of saturated liquid, so that it is dry vapor and it is saturated liquid. So before entering of the condenser it is dry vapor, and before after leaving the, I mean at the exit of the condenser it is saturated liquid. So in the answers, the right answer is A.
It is given that A and B are mutually exclusive events, and we have to find probability of A plus B. That is nothing but probability of A union B. Now we know that probability of A plus B is nothing but P of A plus P of B minus P of A intersection B. Now as A and B are mutually exclusive, this intersection will be always 0. So the required answer is P of A plus P of B, which is nothing but option B. V is a function which is given as x square plus y square plus z square whole power minus 1 by 2. And we have to find dou square v by dou x square plus dou square v by dou y square. Now, v is given as x square plus y square plus z square whole power minus 1 by 2. Let us differentiate it partially with respect to x, that is 2v by dou x, which will be half into x square plus y square plus z square whole power minus 1 by 2 minus 1 into differentiation of x square plus y square plus z square will be 2x, because we are differentiating partially with respect to x. So dou v by dou x is nothing but minus x times of x square plus y square plus z square whole power minus 3 by 2. Now as we need dou square v by dou x square, we'll differentiate it again. If we differentiate it again partially with respect to x, this will be dou square v by dou x square. Now as we have two functions, we'll use UV rule. X into differentiation of this is minus 3 by 2 into x square plus y square plus z square raised to the power of minus 3 by 2 minus 1 into differentiation of x square plus y square plus z square is nothing but 2x plus x square plus y square plus z square whole power minus 3 by 2 will be as it is into differentiation of x is 1. If we simplify, dou square v by dou x square will be x square plus y square plus z square whole power minus 5 by 2 into 2x square minus y square minus z square. Let it be some equation 1. Now similarly, if we differentiate the given function with respect to y partially twice, then the expression will be x square plus y square z square whole power minus 5 by 2. Instead of 2x square, this will become 2y square minus x square minus z square. Equation 2. Similarly for dou square v by dou z square, it is x square plus y square plus z square whole power minus 5 by 2 into 2z square minus x square minus y square. I mean, we'll obtain these equations because they are the given function is homogeneous. Now, if we add these equations 1, 2 and 3, it will be dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. Now you can see 2x square minus x square minus x square, similar to y square and y square z square and 2z square, and this will be common, so the entire term will become 0. Hence the required answer is dou square v by dou x square plus dou square v by dou y square is nothing but dou square v by dou z square, which is option C.
Transform of L of S is, here we know sin AT is equals to E by C. Cos AT, the Laplace transform is S by S square plus A square. So T cos AT is nothing but minus D by ds S by S square plus A square. That is S square plus A square whole square S square A square minus S into 2S, that is 2S square. So minus S square plus A square plus A square whole square. So if we take minus outside, S square minus A square by S square plus A square whole square. That is, option C is correct.
We have to evaluate the integral e power 2x by z minus 1 raised to the power of 4 dz. Now let us consider f of z as e power 2z, and z is nothing but 1 here, and f double dash of z will be will be 4 into e power 2z. Now f double dash of 1 will be 4 into e square. Now by Cauchy's formula, I is nothing but 2 pi by 3 into the value. Value is here 4 e square. Hence the answer is 8 by 3 pi I e square, which is nothing but option B. Minimum value of a complex number modulus of z plus mod z minus 1. Now in order to find this, let us consider equation, which is 1 is equals to 1 minus z plus z. So I'll add and subtract z so that it will be again 1. Now we'll apply modulus on both sides. That means magnitude, which is mod 1 minus z plus z. Now we know that mod x plus mod y, mod of x plus y will be always less than mod x plus mod y. So we'll use this property here. So this will be less than or equal to 1 minus z modulus plus mod z. So we can write this as 1 minus z plus mod z will be always greater than or equal to 1, as RHS is less than 1. So if this expression is greater than or equal to 1, maximum value can be anything, but the minimum value is 1. So the answer is option E.
Two particles with masses in the ratio 1:4 are moving with equal kinetic energies. The magnitude of their linear momentum will conform to the ratio. Here, two particles, let us say m1 and m2, moving with equal kinetic energy, that is, let us say half m1 v1 square. The kinetic energy of the first particle is equal to half m1 v1 square, and second particle is equal to half m2 v2 square. Let us say v1 and v2 are the velocities of the two particles. Here, just take the ratio of v1 by v2, that is equal to m2 by m1, that is 4. So this is v1 square by v2 square. So here v1 by v2 is equal 2, that is v1 is equal to 2 times v2. Now we'll have to find out the magnitude of their linear momentums, that is m1 v1 is to m2 v2. Here it is equal to, here m1 is, let us say m1, and v1 is equal to v1, and here m2 is 4 times m1, and into v2 is v1 by 2. So here it is 1:2. So the linear moments will be in the ratio of 1:2. In the figure given, the link 2 rotates at an angular velocity of 3 radians per second. What is the magnitude of Coriolis acceleration experienced by the link 4? Here is the link 4. So here Coriolis acceleration component is given by 2v omega. So v is the tangential velocity of the link 4, and omega is the radial velocity which is connected to the link, and here it is equal to 2 into r omega into omega, where r is the length of the link, that is 20 centimeters, that is 20 by 100 gives in meters, and here omega square is 3 square, so which is equal to 3.6 meter per second square. So in the option, the right option is D. D is the right answer.